Okay, so this will be 8.2.5. This is testing a claim about a proportion. So you notice, before I read the problem, off to the right there's a rectangle. It has all of the readout. They did all of the analysis. You just have to be able to read it correctly. So instead of writing P, they wrote P-R-O-P, prop, proportion. You notice there's also a P below it. That's why they did that, because they didn't want you to confuse. See, P is a highly used letter in all we do. The top P is proportion. That's actually the P from the null hypothesis, or from the claim, I should say, which goes into the null hypothesis as P equals 0.1. So if the claim is that the proportion is less than 10%, that's what the claim is. That's a left-tailed test. It's one-tailed, it's left-tailed. Remember, the null or the alternative hypothesis always knew what type of test it is. If the proportion or mean is less than, strictly less than, then it's a left-tailed test. If the proportion or the mean is strictly greater than, then that's a right-tailed test. And if the proportion or the mean is not equal, then that is a two-tailed test. That's the three possibilities. So this is a left-tailed test. Check answer. Okay. So we don't really have to use StatCrunch for this. Everything's right in front of us. The z-test statistic is right there. It's minus 1.79. You see it right there. It's the third in the third row. So negative 1.79. See, now the p-value is the fourth row. It's 0.037. Wait a minute, 4 decimals. 0.366. So 0.366, which, if you notice, we're not going to reject. See, because it's greater than alpha. See, this is a 99% confidence interval, and we're at 3.6%, which is greater than 1%. By the way, the null hypothesis, it has to be less than or equal, but this book uses equal, so it would be B. And then decide. Well, since the P is greater than alpha, its P is not low, so we're not going to reject. Fail to reject. So it's going to be A or C. And which one makes a true statement? It says the p-value is less. Well, if it was less, we would reject, so that can't be true. So C is true because the p is greater than alpha. And then the last one is the final conclusion. Well, remember now, the claim is less than. It says the claim is less than 10%. So that the claim is in the alternative. And since we're not rejecting the null, then we're not supporting the claim. We don't have sufficient evidence to support the claim. So can't be A. It has to be C. There is sufficient evidence to warrant rejection of the claim. We're rejecting the claim by not rejecting the null hypothesis. Because if we reject the null, then we accept the alternative, which is where the claim is. And since we're not accepting the alternative, I'm not sure how they're reading this. Let's see what they say. I made a mistake here. Okay, it should be D. There's not sufficient evidence to support the claim. What C is true, but it's in the negative. It's in the negative sense. I didn't read D. Now that I read D, I see it's in the positive. There is not sufficient evidence because we're not rejecting. So that's what they're looking for. They're both true, but D is, if you quote unquote, more true. So that one's on me. All right, 8.2.11 is next. Okay, so 8.2.11. This one we're going to have to use StatCrunch. It says, assume that the adults were randomly selected. That's good. So of those polled, 489 said yes, 397 said no, and 123 were unsure. Politician claims that people don't really understand the stem cell issue, and their responses to such questions are random response. He's saying it's 50-50. He's saying that the proportion of yeses is 50%. If it's a coin toss, then it's 50-50. So we're going to exclude the 123. So the total number that were sampled, if you add 489 and 397, you get 886. So N is 886. That's the number of responses. Alpha is 0.10. Two-tailed test, so it's 5% in each tail. So if the p-value is less than 0.05, then we're going to reject. First of all, which is the correct null and alternative? Since the claim is that it's a toss-up, then that means it's equal, so it has to be A. And if it's equal, the complement is not equal, so that would be the alternative. Okay, now they want the test statistics, so now we're going to go to StatCrunch. Take me a second here. As soon as it comes up, we'll go ahead and use it. So there's StatCrunch. Now, this is a proportion, so it turns out to be a z-test. There's the only possibility for a proportion is a z-test. It's one sample, and it's with the summary data. Number of successes is the number of yeses, because we're typifying those as a yes. 397 was the no's, and the hypothesis is just exactly what we want. We don't have to change anything. Both the value of the proportion and the sign for the alternative are what we want. It matches what we answered in part A. So we compute. Oop, you see what I did wrong? I put observations. I put the wrong number. I put 397, which was the no's. I just looked at the wrong place. I was going too fast. If you add 489 and 397, the number of observations is 886. Okay. I'm glad it stopped me. So it repeats, if you notice, it repeats the null and the alternative, and it also gives us the count, the total. We're interested in the z-stat, which is 3.0908, and the p-value is real low, 0.002. So I'll go back to the problem so we can answer the questions. That was 8.2.11 with a T if it matters. So they want the test statistic, which is the z-test. And it says 2 decimal places. So 3.09. Check answer. And then the p-value, 3 decimal places. That was 0.002. So if you think about it, if you take 0.002, the fraction is 1 over 500. That's 2 over 1,000. So there's one chance in 500 of getting this result. The p-value was set at 1 in 10. We're way below 1 in 10 at 1 because we're at 1 in 200. That's why we're rejecting. We're going to reject the null. So it's either A or C. So there is sufficient evidence to reject the claim. So it's number A. And the final result says, well, the politician claimed it was a toss-up, was 50-50. But it wasn't. In fact, I didn't write it down, but I can look back real quick. In StatCrunch, the sample proportion was 0.552, so it's bigger than 55%. So more than 55% of the people chose yes. And that's significantly different from 50-50. It's not a coin toss. So the politician was incorrect. So it can't be D. So it's D. It says it's wrong. He's wrong. See, since we're rejecting the null, the claim is wrong. Okay, next question. Next question is going to be similar. It's we'll do number 14. I think it's a pretty similar problem. Yeah. So we could do this one fairly quickly. Study of 779, that's your sample size. 479 successes, that's your X. Level of significance is 0.05, and we got to get a claim. The claim is that most of them are dropped. So the claim is that P is greater than 0.05. So that's the alternative hypothesis. Most of them means it's more than 50%. So that's the alternative. So the right-tailed test, and the only one that has P greater than 0.05 is D. So the null is that it's less than or equal, but once again, this book just says equal. So check answer. And then we're going to go to StatCrunch and do the calculation. So once again, it's a proportion. Oop. One sample summary. So there was 479 successes. Those are the cases that were dropped or whatever. 779 was the number of cases. Now in this case, P equals 0.5 is correct, but for the alternative, we have to change it to greater because that was the claim. It was more than 50%. So I compute. You can see the sample proportion. If you look at it, it's 0.61. The 61.5% were rejected. That's much greater than 50%. And you can see the p-value is really small. The p-value is less than 0.001. That means 1 in 10,000. There's a 1 in 10,000 chance of being this remote. And the z-score is rather large, 6.4133. So everything points to us obviously rejecting the null. So we're going to be supporting the claim because that's where the claim is in the alternative. If we're getting rid of the null, if we're rejecting it, then that means that we're supporting the alternative. So it was 6 point. Let's see how many decimals. 6.41. So check answer, and then the p-value. I'm just going to put 0 because it says it's less than 0.0001, so 0 work, which means we're rejecting the null because the p-value is less than or equal. Straightforward answer. Remember, that's where we started when we actually started with the first problem, actually in the previous video. What's the final conclusion? There is sufficient evidence to support the claim because we're rejecting the null, we're supporting the claim. Okay, so that was 3 problems from 8.2. I'm going to end this video here and do one video. Next video will be chapter 8.3. Dr. K, over and out.